session in the series around AI. My name is Noel Ady, this is Loghman, who will be presenting today's presentation on
look like a secondary cause for lots of people. But from 2018, I think, if you want to be more realistic, specifically by introducing the attention mechanism, transformers from the Google, so lots of, I think, attempt try to go to the productionizing the systems instead of just being in the environment, a research environment, and providing and improving the quality of the algorithms. So based on the Gartner research, they said I think 53% of POC or proof of concept they try to make a way and going to the production environment between 2019 until 2022, and as an average, it took around 9 months to make a system or transit the system from a development phase to the production phase. And based on the, I think, Gartner forecast, by the end of 2024, we expect to see 75% of organizations try to move their effort to use the AI in a production environment instead of just the research. And the last one is really interesting, specifically for the people who they want to work in software area. they predicted over 90% of new software application somehow use an AI model or intelligent element inside the systems. So in fact, we can expect lots of more intelligent software in the future. I think it's not far from the expectations, specifically with the pace of the progress after the ChatGPT. And I think because of that is, from my perspective, is a realistic prediction, and definitely we will see more option. And I think, for example, Microsoft Copilot is a sample. How they try to integrate Copilot in every product that they have. So this is the it's just sample to see the attempt around this area, and
it's mostly large. I mean, the stats there suggest this, but it's ChatGPT that's really pushed this. I mean, we ran some projects early on, like with startups and well-formed organisations prior to the ChatGPT revolution. And the confidence was so low, even though the technology was kind of working, it still felt so experimental. I feel like that number makes sense to me because we saw the same thing. People would work on AI, but it wasn't. The confidence was so loose they didn't know how much they were going to end up spending on it. Whereas now, there's the confidence that actually, it's done, it's proven in the wider world, and so more people are doing more POCs and it's getting to production. So those numbers there completely correlate to what we've seen.
Exactly. So if you try to, divide the whole progress in the AI, we can say there is a two phases. The first phase is research and experiment, when we try to ask, I think this is the questions that lots of people in the specific research area try to ask themselves. For example, can AI or ML solve this problem or that problem? Or is it feasible, for example, to apply AI or ML in this area? We face lots of those questions. Personally, I'm just sharing my experience. So I have.
I think you're on mute on there. Sorry.
Oh, really? Oh, I'm so sorry. Thank you. Yeah. So I need to, at least get to start from the beginning of this slide. So, as I mentioned, we can divide the progress of the AI system into phases. The first phase was research and experiment, and the second phase was productionizing their systems. So, in the first phase, we faced lots of questions. Lots of people try to find out how to use AI to solve different problems in different verticals areas. And as I mentioned, as a personal experience, I have a lot of friends in other domains. For example, from the civil, architecture, mechanical engineering, electric, I think every domains. And I constantly receive those kind of questions. Is there any possibility to, for example, use ML in this problem that we have? And somehow this push the AI in a corner for a long time, just to run experiments, to create better algorithms and improve the quality of those systems. And in this stage, in fact, the main focus is on the ML code, or creating the machine learning system algorithms, improving them, while there is a little attempt around the other factors, such as, for example, data collection, data verification, or feature extraction. They try to do those, but it's a small proportion of the whole, experiment and research phase. Or, for example, serving infrastructure, which is a very important factor in the, productionizing system, but in the research or in the first phase, it neglected for a long time. And typically those, I think, kind of scenario was back to the, I think, academic area or scientific research or creating a proof of concept just to validate the idea and create a minimum viable product based on the ideas that the people have. But in the second phase, I think operational or productionizing the systems was get really intensive, and now we face different kind of problem, and the questions could be what strategy can we use, for example, to scale up this model effectively, specifically with the large language model. Oh, really? Thank you. Why? I think it is a problem with the system. Hopefully, let me move the mic. Otherwise, I will change that one, if you notice. Yeah. So, for example, as I mentioned, if you want to use a large language model, it's a really important question how we can scale this model to response or somehow provide the scales or how to answer any queries from the user. For example, if you try to grow from 1 million user to 10 million user in one day, how it can scale those kind of large systems, and it is really difficult. And specifically with ChatGPT, we saw this is possible because it was adopted. I think it was one of the fastest application that has been adopted in a very short time with larger quantity of users. And from that also there is multiple other aspects that we need to think about them, such as how we can, for example, efficiently feed the data to the model, or how we can find the best strategy to gather the data for retraining, because after a while, this is I think a nature of AI systems. The quality of the predictions or the output will be decreased, and we need to gather new data, retrain the system again, put the system into production, or thinking about how we can, for example, establish a A/B testing strategy to provide different version of for example, an AI system to check at least the different way to interact with the user. And in this phase, I think I think I get muted. Let me just to change the mic in my setting. I think it is because of the I will use the internal mic right away. Hopefully it will fix the problem. Great. So in this phase, in fact, AI code or ML code is a small part of the whole picture. We have lots of other components, and the importance of the AI model or algorithms is less than to the other component in the system. Specifically in this kind of scenario, we need to think about the monitoring, setting infrastructure, analysis tools, or process management, resource management, how to scale the system. And as I mentioned, typically those kind of, I think, or this phase is about transitioning AI model from a POC to a production phase, migrating to those. Yeah. And, or sometimes if you want to transfer the old or the existing model to a new environment, you need to consider the operational phase of the AI system. Great. So we understand that there is two phases, experiment and productionizing. But what kind of challenges exist when we are speaking about the AI? I think it's a norm. Always, when we try to create a software, it doesn't matter. There is always some sort of challenge. But as you mentioned, again, AI has some extra challenges that we are not facing during the software development. So in fact, when we try to create AI system, we have different components. At the least, the first difference is the data. In the software development process, we don't have data. Data is static. We will try, for example, to play with the static kind of data. We try to get, for example, data from the users. But for training purposes, there is two elements. One is code, one data. So code could contains all the algorithms or model architecture that we have, at the same time the configuration, hyperparameter related to the models, and all those kind of information. And the data have different element again, data validation or shuffling and splitting data for training, testing, evaluating, and transformation of the data when we try to train. So feature engineering also is another part. Then we can train the model, and finally we will get a model as an output. And we can analyze this model, but as I mentioned, code and data, they are independent. They can behave completely independent from each other. So in this case, if the data in the production environment change, so we will face some sort of problem in the performance of the model. So during the development, we have some challenges such as development, training, and deployment environment. They can be completely different environments. Specifically, if you want to track the cost of the training. So we will try, for example, let's say, we will try to develop our code in development environment. But we want to push the training process to a different environment to track off the cost for training. And then we will grab the train model and put the model inside the production environment, which is the inference phase, and it could be completely different from the previous. So how we can track all of those, how we can somehow align the different environment together. This is one of the challenges. Tools library dependency is another challenge. Specifically with the Python, I think, because it has a very dynamic ecosystem compared to the other languages. For example, now in Gravity 9, I think you can explain better than me, the main technology we are rely on the .NET and Java, I think.
Yeah, obviously .NET, Java, React.
Yeah, and they are coming from this, for example, one source. So, for example, we don't have any some sort of conflict between, for example, if you try to use the C# or .NET, so there is a stable versions of those kind of frameworks. But with the, let's say, for example, with the AI system, so you need to combine different pieces together, and lots of time they are not compatible. For example, a frameworks maybe use the Python version 3. For example, 8. Another framework uses Python 3. For example, 2. And when you try to put them together, there is some deprecation features, and you will stuck in the middle. These are just some samples, but I think it's one of the challenges. Tracking and analyzing experiment also can be really difficult because it's not look like a code. In the software, we have the code version control systems such as a Git, GitHub, and we try to track the different versions. But in the AI, because we have the data, so we need to have a different version of the code. And during the training, we will not get the best model with the first, I think, iteration. We need to repeat multiple iteration, use different version of the data set to train, tweak the, for example, architecture of the model, and then finally when we get the output, sometimes you will be really confused what version of the data has been used for training of this model. Repeating those experiments get really difficult. And as I mentioned, yeah, it is some sort of challenges that we face in the development phase. And in the production phase, we have another challenge. Live data is not equal to the training data. It's a very common and usual challenge. I think I mentioned multiple times, during the COVID, we faced this problem. So suddenly, all the people try to buy everything online. The behavior changed. Lots of the AI systems trigger their alert. And they said there are lots of anomaly in the input data. Why? Because behavior or the environment was changed. The data, in fact, the style of the people or the behavior of the user change and impact completely on the AI system, specifically in the banking industry. Feature engineering pipeline, because we need to transfer the data and then pass them to the AI system. So we need to put those pipelines alongside the model into the production environment. And scaling up or down of the AI system is, again, could be another challenge, as I mentioned. Retraining or, I think, creating the best model after a while, because there is always a loop in the data, in the AI system development. You should put the best trained model in the production environment and gather the information or new data that is fed by the user, and then again use those data to retrain and improve the quality. So for example, now when we are using the ChatGPT, every day they try to collect new data set for training next models. And different technology landscape between development and deployment, as I mentioned, it could be another problem.
Is it best practice to be closing down, so you're going to use your, let's say your SIP or your UAT environment, do you get through that, you close it down, presumably because is that built into the automated pipelines that you close that out and then move up to the next environment, or do you continue training in those lowers and as you move it up? How have you seen that work?
I think the best practice is to continuously monitor the system in the production and automate the process of the monitoring specifically, and setting some sort of alert to inform the developer based on the performance of the model or the systems. And then there is some sort of threshold that you need, and it is, I think it is based on the business requirement or objective from the AI system. So yeah, having those loops is important, but definitely we have the automated pipeline to go through the whole process.
And do you then are you also pulling down production environment down to the lower environments for to increase training? So in that scenario where you had a shock in the banking system or COVID, so you would take the information that caused the shock and bring it down to retrain to consider that. Yeah.
Exactly. It's a part of the process. So let's look at those challenges with one example. For example, if you try to create a facial expression recognition system and use this, so using a medical, for example, application. So what we need to do at the beginning, we need to collect the data set just to train. And train the model, and then when it comes to put the model in the production, there is lots of questions that we need to think about. The first question is, about the deployment environment. Are we going to deploy this model on the cloud or on an edge device? So it's make a big difference. Specifically, if you want to, for example, deploy a model on the edge device, you need to find a way to downsize the model, and sometimes it impacts the quality of the model to be integrated in an edge device. By the way, after deciding about that, or maybe you will be okay to have, for example, your model, an AI prediction on a cloud server and having a constant connection to send a request and receiving the responses. So those are just the beginning. Okay, when we decided to deploy, where to deploy, now it could be other challenges.
Right, sorry, just to clarify, on edge you mean a device?
Exactly.
Not a device, a small device.
A small device.
A small model to do something locally.
Exactly. Maybe it could be an IoT device, or let's say, for example, it might be a mobile device. So integrating in a mobile application. And this is one of the experiments that's really not nice. Specifically, if you try to, because all the new or good model, they have a big size, and downsizing them, shrinking them. There are lots of different techniques, but it's not easy, and it impacts the process. Now, okay, we deployed the model, but still we face, this is a real environment. It's not a bunch of text or numbers. The input can be everything. So for example, we want to find somehow the system is based on the facial expression detection. So, but it might user have some sort of item in front of the user. We cannot see the whole face of the user to predict that one. Or maybe the lighting condition in the environment is not good as enough compared to our training data set. Or maybe the user tried to use different styles, accessories, so we cannot predict that one from the beginning. And because of that, it makes it difficult for AI systems, specifically. Specifically, the QA process of the AI system is a little bit difficult because the input is really, really not predictable. It's not static.
Heuristic as opposed to
exactly
deterministic as a traditional approach.
Yeah. And now we have two groups of challenges, generally, if you want to think about the AI system. A group of challenges related to the software development, such as, for example, real-time or batch. Do we want, for example, to send each item and receive the prediction, or we want to gather all the data, for example, a group of data, send the data as a batch, and then receive the prediction? Or do we want to deploy on the cloud or edge, as I mentioned, or browser? What kind of computer resource do we need?
When you say a batch, do you mean like, I want to process this parallel with these photos, or is that a particular scenario?
Yeah, for example, in this scenario, we might want to, for example, gather 20 different photos from different people, send to the, as a batch, send to the, because this is a more cost-effective way if you try to run the inference as a batch instead of running as a real time.
Yeah. So also application characteristics. Yeah.
Exactly. And then computer resources. Sometimes the device that you selected maybe need some sort of specific resources, such as a GPUs or a specific amount of the memory. I used in one of the projects, for example, I used a GPT-Neo, which is a small version of GPT-3. And it was around 10 gigabytes, just the model. was 10 gigabyte, and so when you load that model in the memory, so what kind of other resources do you need and remain for you to use, for example, and run the other processes of your application. So you need to think about lots of elements in these cases. And latency or throughput, for example, when this is I think a question specifically for the scalability of the systems. When we have, for example, this system in the production, how many, for example, in this case I said query per second, for example, ChatGPT, how many, or a conversational model, how many query it should be response in 1 second? Do we have enough resources? Is it really enabled to provide that much output? And logging what is going on underneath and inside the system, security and privacy is another aspect. So those software related. At the same time, we have AI and ML challenges. And the first one is concept or model drift. So concept or model drift, in fact, when we say model, a model tries to map X to Y. But in the real world, sometimes this mapping will be changed during the time. Let's just say, for example, we have a model for recommending product to visitor of the online shop. So, for example, we trained this model with the product of last year, or maybe past 10 years. In the new year, designer somehow changed the way that they design, for example, the product. And the new trend came to the market. So the whole concept between the X and Y changed, and now we need to retrain. And the recommender system that we trained is not suitable for the new trend because it doesn't have any idea. And this is the place that we call concept drift. In fact, the whole concept is changed. We need to restart from the beginning, preparing new data. And data drift, when the data can be, the feature of the data can be changed, or the shape of the data. For example, maybe user prefer to use the audio instead of the text after a while. So in this case, we need to change our approach. Maybe we need to completely change the model. Any comment? Any?
Sorry, just around pricing, is there a standard mechanism for sizing and pricing a model? I suppose you get used to it as you're going through and it becomes iterative, but there's no sort of standard approach to do that.
At the moment, no, because there is a multiple, specifically for the, I think, a cloud provider at the moment, if you look at the, let's say, for example, Azure or AWS, what they try to do, if you want to have to deploy specific models, let's say, for example, a large language model, they offer two different versions. One version you have, you need to have all the computing resources to load the model on those resources and use that resources as a private resource for yourself. Or as an alternative, they have another option, pay as you go or pay as you use. For example, there is a shared version that you try to use, and they will try to share this model between different users. And then, but by the way, for the pricing, there is no standard, to be honest, for the systems. And one of the differences again with the software, I think, is here. Any thoughts? Any comment?
When you're shrinking the models down, is it a linear relationship between the quality of the output? I guess it's probably not. It probably gets exponentially worse, the output. As you
100%, exactly. It depends on the size. So we have different techniques. For example, quantization is one of that. So in the quantization, in fact, when we train the model, the weights will be stored, and we will use those weight. So in fact, the model is just bunch of numbers, and we try to use those numbers. The number for the big model, they are float number. So when we try to shrink, for example, in the quantization, we will convert those float number, round them to an integer number. So they lose the part of the information.
Preciseness.
Exactly the preciseness that they have.
So,
And
just the question, I repeated
Oh.
online, but the question was that when reducing a model to get onto an edge device, for example, is there a correlation between the reduction size and the quality of the output?
exactly. Yeah. And definitely it will impact the quality. Brilliant. Is there any other thoughts, comments? I think compared to the last session, which was generative AI, I can see less energy today, or maybe.
I'll wait until we get the end. Is there how often a ChatGPT sort of retraining goes like this? Is there any statistics?
They didn't publish any formal, I think, document about the retraining process, but retraining periods. But I think they try to reuse all the data and specifically gather more information. And I think it's normal. As I mentioned, they should have some sort of monitoring system. They have. And they use that one to find the point that they need to again retrain. And specifically, for example, with GPT-4, the speed was really low, and I think users felt the throughput out there. You could feel the impact of the model, and because of that, they did some changes, and I think they retrained. So now the new version, the Turbo, is much better compared to the original one, much faster. So we mentioned about the challenges. Now we want to look at the other side. What is the solution? And as I mentioned, MLOps, but let's to see why we need the MLOps. The first, I think, reason is about the speed of the process. So in fact, with the DevOps, we have the same concepts. We want to have a continuous and faster delivery. We want to have a faster modifications in our systems, and specifically bug fixing should be very quick. So the first, I think, reason. Then, as I mentioned, it's an experimental process for the AI system. In fact, we want to run faster experiments every time and integrating the best output of those systems in the production environment. Again, another option. Scalability. How to scale the system and how much it's easy to integrate a new AI model. Standardizing the code for the system and the model, and lower operational costs to scale down or scale up the model or AI system. Time to market, I think, is an important factor again. If you try to follow the traditional techniques, it will be difficult to specifically introduce the product on time to the market, and specifically with the loss of competition in this area, we will be behind. And finally, business owners can have a stronger collaboration, and it will improve the iterations of training. So all of those elements somehow, the main reason is the MLOp. But what is MLOp, in fact? This is a, I think, formal definition from Microsoft. They said MLOp is based on DevOps principles and practices. In fact, I think the whole concept is, in a sense, some sort inspired by the DevOps processes. And it tried to increase workflow efficiency like continuous integration, deployment, and delivery of value. So the value is really important. In fact, the whole attempt is to deliver value using the MLOps. So this is the representation. In the DevOps, we have Dev and Ops. But in the AI, we have data and ML. And because of that, data plus ML plus Dev and plus Ops equal to MLOps. So it started from the collecting the data, curating a data set, transforming the data, then validating those data, exploring, if you remember we mentioned about data exploratory analysis, training a model, evaluating the model, then writing the code to integrate the model inside the software, then build the system, test this system, release the system, deploy, put the system in the operational environment, monitor this one. Based on the monitoring, we can plan and go back, formulate the plan, and again start the beginning. So it's a loop between different elements. And I think because of that, somehow, specifically for DevOps teams, it gets difficult to adopt themselves with the MLOps because they need to think about the extra items such as the data and models. And the whole MLOps concept is just, as I mentioned, for helping the reproducibility and version control. In fact, we want to reproduce the same experiment that we had during the training and automating and scalability, model performance monitoring, and finally collaboration and teamwork. There is a difference between DevOps and MLOps. So, for example, both of them, we have code versioning, we have computer environment, we have continuous integration and delivery, and monitoring in production. But MLOps has data, in fact, versioning or provenance or data sets. Definitely, we need to have a list of the data set, different version of the data set. We have models. It's not just one model. You need to version, have a multiple version of the model, hyperparameters of the model during the training, metrics for evaluating the model, and workflows to pushing the model to the production environment. And finally, this is the another, I think, concept is model ops. It's presented by Gartner. They said instead of ML ops, you can have the model ops as well. So the model ops is combinations. I think it's a separate. They separated from the ML ops just by focusing and emphasizing on the model part. So we have the data ingestion, data cleaning, feature engineering, model development, and model training. So those are related to the, in fact, MLOps, but from the other side we have the model or MLOps that is all about the model, such as a model validation, model deployment, model operation, and model monitoring. And it has some sort of overlap or similarity with DevOps. Any thoughts? Any comment, question?
That's a new ops on me, so nice. So you could say MLOps is DevOps plus models, basically.
Exactly. Yeah. In fact, if we want to, I think, look at the data pre-processing, data preparation process, and I think data science part of the process, it will be MLOps. But from the other side, when we try to go to the model training, evaluating, and monitoring, it will goes to the model ops. So it's new concept, but I think everybody try to use different, I think, terms or phrases to refer to this process, but it's similar. Some of the, I think, big names in the industry, they refer to the whole process as a MLOps. Some of them, they try to divide it.
Often we're pushing to the same environment, so we can reuse some of the same tooling, like GitOps or
100%.
DevOps. I mean, the workflow and the mechanisms feel like they're the same thing, but you're maybe pushing a Python.
Yeah. So this is the difference is that. So for example, now for the code, what we have the GitHub or a Git repository, but where we want to store, for example, different version of the data, where we want to store different version of the trained model, different version of hyperparameter for those models. So this is the difference, and I think it make the whole equation more complicated.
And presumably more time consuming pushing your
Exactly.
pushing your model and your data through the environment. It's going to take much longer. Presumably, like, rather than a few minutes, it's hours or potentially days.
Days, exactly. And if you try to look at the whole practice for MLOps, there is different rules, and it starts from the business stakeholders when they try to find a business problem, and then we have the data engineer and data scientist or ML engineer who they try to, for example, work on the data, prepare the data, train the model, and create a different version of the model or model artifact, put them in the model registry, and from this step, somehow we need other people with different, I think, skill set, such as a software engineer or DevOps engineer, to help the data scientist or ML engineer to integrate the system inside the bigger picture or software, and then push that into the deployment environment. So this is the deployment pipeline. And as you can see, there is a feedback from the operational environment to the previous steps, just to check the quality and constantly monitoring the operations.
What is that feedback? Is that conversation, or is that a technical pull down of data and automation?
Yeah, so this feedback, it could be the data that is collected during the operation. It could be some sort of automated pipeline that trigger the process for automate for retraining, because we can automate the whole process of the retraining, and it will start retraining the model, and if the model get a better performance, again it will push it to the production. Yeah.
Am I right to say that in a lot of contexts, where you have software engineer and DevOps engineer, essentially they are called MLOps engineers?
Exactly, yeah. So
you have a data scientist and you have machine learning engineer whose responsibility is to productionize data scientist model, and then you've got the MLOps engineer which does the DevOps work.
So this is I think, yeah, to clarify, let me repeat the question. So the question is that software engineer and DevOps engineer in these diagrams somehow represent the MLOps engineer. In somehow I can say yes, but from the other side, it could be no. Why? For example, sometimes if the ultimate goal to, for example, put the model into environment production and using this model just as an API, for example, providing a REST API to use the model, yeah. But if you try to integrate this model inside the software environment, definitely you need to have some sort of software engineer and DevOps people to help you to somehow
Like the UI, for example, or bring that model into the actual
Exactly.
That's source.
And because of that, is really, as I mentioned, is a fuzzy, still fuzzy concept, and lots of people have these confusion in the between. So now we saw those problems. We will go to the very different page, responsible AI. But before looking at the responsible AI or ethics around the AI system, we need to, I think, look at some of the problems in this area. And the first one is the harm and the risk around the AI system. I think specifically by increasing, as I mentioned at the first slide, if you remember, we aim to see lots of AI system inside our software applications very soon. So how we can control those systems, how those systems can harm and how they can provide risk. This is one of the main researchers, again, I try to use the Gartner research, and they said, for example, there is a different type of risk associated with the AI system, from the bias and discrimination. So, in fact, when we try to create the AI system, it is look like they're replicating ourselves. Why? Because we are using our data. And if you have a bias in our data, the model perpetuate these biases, try to increase or maybe make a terrible impact on the people's life. And I will show you some samples in the next slides. Or another risk could be restricting individual from different aspects, such as the autonomy that they have, or the right or resources that they access. So AI system can impact and somehow restrict people in some cases. I will show another example in the next slide about that one. Lack of transparency. I think this is a very important one, or explainability. So they all look like a black box. The developer, they had a difficult time to explain what is going on inside those numbers. It's really difficult. So when we cannot explain, in fact, it can impact the people's life, and is not transparent for everyone what is going on inside those boxes. How, let's say, for example, if you have a model, AI system to check the eligibility of the people for a loan, very simple example. So, is it really easy to explain how this model decides about the eligibility of people? Can we explain that one in our natural language, in, for example, 1 or 2 sentences or not? So this is the part of the process that make AI systems.
Is that due to a complex set of derivatives, so you just can't pin it back to one thing? Is it almost like a hallucination?
Yeah.
So you can't pin it back to a number. So there's maybe 5 metrics of consider your credit score, but it's come up with something different, and it's complex set of derivatives come there, so we can't.
Yeah. So for answering your question, this is so difficult to find the source of those, for example, sections. Let's to say finding the relation between, let's to say, if you have a specific group of people which the model try to discriminate and, for example, reject them for the loan. So finding the relation between those group of people with the structure of their models is not easy. So finding the lineage between all.
Yeah.
And from the other side, because specifically with the neural network, they are just numbers. We have lots of techniques to visualize, but it's not easy for some of the,
You can't get down to an execution plan and say, I came to this. It's a mathematical calculation.
Exactly. Yeah. And then, again, uneven legislation, lack of guardrails, and security and privacy. This is, I think, very clear. Risk around the AI system. When we cannot specifically, let's say, if we want, this is just sample. If I'm a user of ChatGPT, I'm using the ChatGPT today, and let's say maybe I make a mistake and I pass some personal information to the model, and then they will use that data for retraining or training a model. Now I cannot claim that data. They can remove from the data set, but the model that was trained using that data is so difficult to somehow shut down the model or maybe bring it down, because they spend lots of money on that kind of systems for
reinform it and retrain it.
Yeah. So because of that, I think there is lots of kind of privacy and security concept around those systems. And another thing is isolation, and this one is really interesting. So AI model can treat people, different group of users in different way, because they are not predictable. And in this case, they can separate people from each other or isolate them sometimes. And unreliable, unsafe, complexity beyond comprehension. Again, the same things that we mentioned in the, I think, previous items. So those some sort of risk and harm that can be around. But
the isolation, is that similar to sort of the control problem in a genetic algorithm? So you might end up in a trough of information, but you don't know what's up here on the peak because you've not scattered your search space. Is it a similar problem that you can bucket into areas of? Yeah,
it's very similar. Yeah, I think we have the same problem, and sometimes, as I mentioned, by the specifically with the bias, I think the system can treat different people in a different way. So I think the root of the problem could be bias, and the result will be interesting. So let's understand the bias. If somebody showed this photo and ask what is in this image, so what you will say? Somebody, what?
Looks like a watermelon.
Watermelon, exactly. Any comment? Watermelon. That's true. This is a watermelon. Yeah. So for example, we say watermelon, or maybe watermelon slices, or maybe we can say watermelon with seeds. But how about red watermelon? How you think about this as a red watermelon? No. Why? Because in another place on the planet Earth, we have a yellow watermelon. And now, if we see that one, we will say, yeah, this is a yellow watermelon. It's a yellow watermelon slices. So, in fact, as a human, we are really good at generalization. We try to generalize all the concepts to somehow decrease the complexity. So, and this is the root of the bias in lots of, I think, AI applications specifically. So, in fact, because the red is some sort of default value in our brain for watermelon color, we try to avoid to mention that one. And having those kind of prototypical, I think, concept, it leads us to be biased. So, example of bias, to see some of them. Google Translate, I think everybody used the Google Translate, yeah? So let to show you a very interesting and how it is still has, but I know that it's so difficult for Google also to mitigate those kind of bias. So for example, if I wrote down, she, fuck, doctor, and he is a nurse. Okay, so she is doctor, and he is nurse. Okay, let's translate that one to Persian. In Persian, she and he is similar. We don't have any gender to, in fact, separate them together from each other. And retranslate that one. So, he is doctor, she is nurse. Why? Because in the trained model, the probability of a male to be a doctor is much higher compared to a female. So, this is one example. To go back to the presentation. Another one in the UK is from the BBC. So, the UK passport photo checker. So they used an AI system, in fact, and they found it showed bias against dark-skinned women. And multiple times they had to upload their photo. It was rejected. And finally, after receiving lots of complaints, they shut down the system. So this is another example. Or I think the famous one, I go back to here. It was the gender shade in 2018. So, all the big brand, Microsoft, Face++, by that time, 2018, they were one of the, in fact, famous player for computer vision in the market. And IBM. This is a result of MIT research. They found out how much their system is unfair compared to the different people, specifically with different, I think, skin colors. And there is a nice documentary, if you like, you can look at that. And you will see how it can impact on the different areas. So why this kind of problem or bias will be happen? And how AI can replicate the same bias. I think the basic concept is data set bias. In fact, in our data, we have some sort of bias. For example, if you train a self-driving car using an environment of one city, and then try to sell those cars all over the world, so definitely it will not work. And for example, if you train on the UK and send that one to the
wrong side of the road.
yeah, so it's so different. Or when we try to, for example, look at the data, we have a different demographic for the people. We need to have all those demographics in our training data. Or if you try to use, for example, very polished, nice photo during the training and then put the system in the real environment. Or if you try to think about different cultures that we have. So those kind of concepts should be considered during data gathering and creating a data set. The inclusiveness is an important factor for AI system. Any thoughts? Comment? Yeah.
What do you mean by bias? One location to another, what does that precisely mean?
Okay. So for example, let us say a self-driving car. Okay. We, in UK, as I mentioned, we need to have at least a rain jacket or something like that. So, because always here we face raining, the weather is raining, yeah? So, the model will be trained on the people and they try to, for example, identify people and all the people wear some sort of full clothes. But if you try to use the same model, the same system in a place that is very warm and people try to have a less clothes, or maybe if you try to use that car in a place with the snow, so the system doesn't have any idea, and it miss, for example, identification or miss object, such as a human, using the model can lead to the loss of people's life and can cause damage to them.
Yeah, so the question was just around what was the explanation of the bias with the example related to the car and the self-driving car. But it sounds like it's more to do with just lack of data or visibility of circumstance or individuals. So it's breadth of data.
It's about the data. So in fact now, as a trend or best practices, I think what we can do to have more inclusive data, at the same time have a diversity in the developer team, the team that they try to create the AI system. So because of that, diversity is really important to specifically to have people from different cultures, as I mentioned, or from different locations. But at the end of the day, the data set is really important because all the knowledge will be extracted from that data set.
Just one thing, when we talk about inclusivity, is there any percent of particular type of data so that it is actually giving you effective results?
So there is a different techniques. We cannot, it's so difficult to be honest to sorry. Yeah.
I forgot the question actually.
So
no,
I will repeat that question. So in fact, the question is about how we can find how much, for example, what proportion of the data should be considered, or what kind of different kind of data should be included in the data set to be inclusive. So at the beginning, it's so difficult to find that, but what we have frameworks or tools that we can analyze the fairness of the trained model compared to the different part of the data or the users at the end. So in fact, and then we have different techniques to fix the problem of the fairness during the training and after the training as well. Yes.
So I'm wondering at what stage in the development process alignment happens and the kind of guardrails. So, for instance, if you ask a question about gender to ChatGPT, you'll get a very different kind of response to if you ask Grok, Elon Musk's, and so within that, and at some stage, it's a kind of decision which is embedded in the system itself, and it's not an accidental bias. There's some level of decision that's been made. And then also I'm aware of some open source large language models which seem to have no guardrailing in place, in which case it's then the responsibility of the person fine-tuning the model to implement some kind of guardrails or alignment to their particular focus. So when in the development does alignment happen, and speak on that?
Yeah, so the question is about the alignment and the guardrails when we try to consider them during the development or maybe productionizing the specifically large language model or AI system. So the guardrails should exist from the beginning, and it's a part of the responsible AI. So I'm just trying to speak about the problem at the moment. In the next slides, we will see how we can think about the guardrail, how we can create an umbrella to somehow cover the whole process, the people, that society, I think organization, and the final user, or I think the whole process of the development as well. So this is the responsible AI concept. And for the open source, as you mentioned, when we have the products such as, for example, ChatGPT, that is managed by a company. So they try to follow the guardrail, and they try to develop. It's not, unfortunately, there is no standard version of those guardrails at the moment. And this is one of the debate. I think we don't have any regulation or enough regulation regarding the AI systems, and we don't have a standard way to follow to have those guardrails. But there is just some sort of best practices that you can find. And for the open source, at the end of the day, the people, until I think at the end of the day, those open source models, if they try to be used in the production or in a product, they should be, the developer should be considered those guardrails or having some sort of alignment. Otherwise, it can cause lots of problems, as I showed you in some samples. And I will show you some other more in the following. And the main response for the whole problems or those issues is responsible AI. So in fact, in the responsible AI, we try to create an umbrella to think about different aspects. So again, from the Gartner, so responsible AI is about the accountability, privacy, regulation, fairness, equity, compliance, interpretability, trust, intellectual property, risk, management, explainability, ethics, security, transparency, cultures. All of those should be together and should be summarized in one framework as a responsible AI. And using this framework, you can cover or protect society, organization, and customers, and generate value out of the AI systems. And as a standard at the moment, as I mentioned, every I think different player in this area, they try to introduce different framework, but they have common elements. I think at the moment they reach to the level that they said they have a common element that we need to consider. So this is the, I think, formal definition of responsible AI. Responsible AI refers to the development and use of artificial intelligence in a manner that is ethical, transparent, accountable, and ensure fairness and safety for all stakeholders. So, another example here. Collaborations, pharmaceuticals. They are a private company based on the state. They try to use the AI for, in fact, drug discovery or some sort of creating medicines for really rare problems or diseases. And it was really interesting. They, I think, they invited the head of their research department for a conference to talk about the risk and harms that AI can cause. And they started investigating about their systems. They said that to see really, is it possible to AI harm anybody? And interestingly, they used their system, and one of their developers, just by changing simple input to the model, instead of creating a useful drug or some sort of medicine, it pushed the model to create the most dangerous chemical material using the same model. The first attempt or the main aim of the model was to help, but by changing some input, they push the model to be very dangerous. And this is the place, without having a responsible AI, we will be in a very bad place. So the first element is fairness. I think I explained fairness fair enough. When AI systems should treat all people fairly or equally. Reliability and safety. This is another aspect of the responsible AI. When AI systems should perform reliably and safely without harming anybody or impacting on people, specifically for the critical applications. Privacy and security, again, another aspect. When AI systems should be secure and respect privacy of any users. Inclusiveness, I think we mentioned, treat all the people equally. Transparency, we need to understand the whole process specifically. Let us say, for example, transparency is not about the output, it's about the process of the training. For example, if we try to share some things, or if we try to gather data, we need to be transparent with the people who they try to provide those data. And we need to get the consent, and we need to share how we are trying to use those data, how long we will keep them, and accountability. This is very important part, and because of that, people who they are working in the AI area is really have difficulty. They are accountable for everything, for any impact that those systems can have in the future. So, because of that, I think, yeah.
So, based on the premise of responsible AI, the premise rests on the individuals or the companies or the groups to determine what makes a responsible AI. But there's obviously conversations around the legislation, because that legislation that's put in place at this stage, which we're actually quite far from, we're much further ahead than we should be in terms of this legislation. Won't it become difficult for us to implement these parameters? If we use the example of the internet, where we're trying to bring in legislation now, how many decades down the line, it becomes almost impossible to roll back to where we are, where we can actually put the right safeguards in place. So when we're looking at all the parameters of what makes a responsible AI, this is very much on the individual responsibility, and isn't there a bit of a contradiction there in what we're talking about?
I agree with you. So, in fact, yeah, regarding the regulation, I think there is lots of debate, specifically last year. If you go back and check the news, a group of scientific people and companies, specifically the big, I think the major player in this area, they try to push the government in the state to think about some sort of regulation and formalize and provide some sort of guidance around those systems. So always, yeah, they are behind. And as you mentioned, the same concept with the internet, it will be the same, I think, with the AI. We will face the same things. But, however, at the moment, the main, I think, focus in the market or the main effort from the AI system developer and provider that is try to formulate the concept of responsible AI and consider during the process of the development and also using those systems. And it's not an easy, I think it's not an easy process. By the way, it's a responsibility for the people who they try to create those systems, put them in front of the user, and because of that, the last element that I mentioned, accountability, is part of this framework. And they try to be accountable for everything. And for example, I think, I'm not sure, but I'm aware about the case of the OpenAI in the court. So they use the, I think, financial,
Is this the loss of Getty, where they're scalping a lot of information from the system and feeding that into
Yeah.
the AI system?
Yeah. So, in fact, because they have their responsible AI framework, they feel that they're accountable, and I think they find, the court find them, and they accept that. Yes, it should be.
I mean, it's a good area of discussion. I think it's. I mean, I suppose it comes down to. I think the original question was: is the individual sort of responsible around the model? And I think that's difficult. And I suppose even in traditional development, I mean, we just had that recent post office issue and scandal. We don't need intelligence to sort of ruin people's lives. So I suppose it's a similar problem, isn't it? We've had it for a long time with the internet. Custom systems. There's an area of responsibility we all have to implement.
I think maybe that's what I'm trying to point out. There's nothing wrong with saying a person or people that are developing should have a personal accountability, but people are fallible. I think that's a consistent fact we can always look at. So one needs to look at other parameters in which that can be other systems that are put in place to implement and quote unquote, this is going to sound very dictatorial, encourage people to move away from their intrinsic fallibility. But that's for future discussion, I guess.
Yeah.
Yeah, it's good. I mean, I'm sure we could debate ethics around the IT and AI, but yeah, it's a major part of, and I think certainly from our perspective, when we engage in an AI, that it's something we bring up proactively to talk to clients. We need to think about this and the safeguards that we need to think about, because there is liability there, so we need to work through those real problems.
Yeah.
Maybe they're trying to put safeguards in for that. Like for example, when you get into Azure and you use stuff, they make you sign a bit of a disclaimer and you're not going to do anything bad. And equally, I think did Microsoft recently announced last year at their conference that they were putting it off, what they call it, privacy shield or something like that. So your company can't get sued for example, if the AI model produced some code and you put it into your product, and then who owns that code? Is it? And I think they privacy shielded him and say, well, we'll accept anybody trying to sue you for using their images or whatever the code or whatever it may be for that. So I think there were some sort of, you could overkill this as well, because how far do you go in that US culture where you're trying to sue everybody for everything, and you've got to be careful. So I think they'll try to put some.
I think this is I think the main reason that I mentioned lack of regulation always is really make it difficult, because everybody can think about different rules for themselves, and as you mentioned, they might have some sort of shield for privacy or personal information, but in other cases, because there is no force to, for example, push all the people in the same level or treat them in the same level, so they can somehow use different, I think, processes. Yeah.
And I'm sure it's just on that note, I think some solutions are probably riskier than others.
Exactly.
And it's all about the use case and what problem you're trying to solve. I mean, some of the problems we're solving is more about abstraction and understanding, comprehension, regurgitation. Whereas, if you're trying to upload photos to the photo, I can't remember the example there, but you can see the risks there. I think to evaluate each one by one based on its outcome and its influence on the end user or the consumer.
Yeah, that's true. So I think all of them is based on the use case. And the last part is about the evolution of responsible AI, and I think this is just a recommendation from Gartner. If you want to, for example, develop a responsible AI framework, you can think about 3 phases: foundational paths, stability paths, or transformational paths. But it's an incremental process, so in fact, there's 5 different components that should be considered during the creation of the responsible AI. Data foundation: what kind of data do you need to have, what kind of systems and procedure you need to have inside your, organization. Strategies and planning. development and execution, and value generation. So those are 5 main, I think, items that should be considered in a responsible AI. And each of them, they have different components. For example, strategy and planning. For data and analytics governance, what kind of, for example, strategy an organization should have to, for example, manage their data, or internal and external readiness. Are they, for example, ready to, for example, develop an AI system or not? Communication and metrics, what kind of metrics they will use for example, evaluate their systems. Or development and execution, delivery and operation, for example, what kind of style or frameworks or I think approach they will try to adopt for delivery, and how they try to focus on the result. All of those components should be explained in the responsible AI. Or for value generation, for example, how adoption of those systems can generate value for them, or what kind of employee or computer or computational system can be used, or somehow in fact empower the employee. Those systems can empower the employees or computer systems that they have, and how much they are reliable and safe. And in the second phase, there is a new element, look like it, for example, for data and analytic governance, so compliances and regulations should be there, or for external and internal, for example, readiness. They should define the rules and goals and so on. So I think there is a different stages for developing responsible AI framework, and this is, I think, the last one is some sort of comprehensive style of or responsible AI framework that could be considered. And as you can see, it has lots of components, and all those components should be clearly defined, should be clearly adopted during the whole process of the system developing, and also productionizing the AI systems. For example, human-centric inclusivity in the value generation. How much, for example, human involved during the value generation? Is it really use the human, or I think we have the feedback from the human to, for example, track the quality of the, for example, trained model or systems. So as I mentioned, there is, we are in the beginning of the process, but responsible AI is a tool just to protect us from the harms and the risks that generated by the AI system. So I skipped lots of components here, to be honest, because I think it's enough. You need to just dive and study by yourself. Just to give you an idea what is the current state of, I think, progress in this area. Any thoughts?